There were two events in my life that fit the question, where were you when? And I will not miss a beat to give the answer. One was the Kennedy assassination. The other, well, it was probably 8:45 on September 11th, 2001 when the phone rang. I would have missed that call if it had come 2 minutes later. For once, I didn't have CBS News 88 on the radio because I was going to take advantage of the clear as crystal, blue as a Caribbean sea sky, and go to the beach. I took a quick look at the caller ID. It was my son Michael, calling from Rockville, Maryland, a suburb of D.C. I never miss his calls. "Hi, Mom, did you hear anything about a plane flying into one of the World Trade Towers?" "What?" I thought. "No, I was just leaving the house. Didn't have the radio on." "Put on the TV," he said in a strangely quiet and calm voice. The TV was too far away, so I punched the on button on the radio. It was now 9:03 a.m. The second plane flew into the middle of the South Tower. Together, like the appropriate Greek chorus to this tragedy, Michael and I yelled, "Oh my God, oh my God, oh my God. It's terrorism," I said, moving to put it on the TV. "I have to go, Mom. All hell is breaking loose here. I'll call you later." As I watched things I wish I had never seen happening like a bad Godzilla movie, Tom Brokaw got me through the day. As the second tower fell, I thought of glass breaking, the glass in a window to a new, unknown, and frightening future world. And God have mercy, all those people, the loss too great to comprehend. The final death toll was far less than originally imagined, just under 3,000. But to the thousands more of victims' families and friends, each one was more than too much. So many remains were yet to be recovered. Where were they? How would they be located? A year later, the first anniversary 9/11 memorial service was a yearly tradition. 15 years later, such was the impact on the soul of New York City. That first Memorial Day was very windy, and even though a ceremony was held in what had become the Ground Zero construction pit, that wind was able to reach down and raise the dust from the floor of that pit. The mourners and participants were enveloped in wisps and clouds of sandy-colored dust. That's them, I thought, the spirits of those who were atomized by the heat and fire, by the compression of those pancaking floors traveling to Earth at 32 feet per second. The dust is all that remains. It was why so many referred to Ground Zero as hallowed ground and fought so hard to preserve what they could. It was the last resting place of so many. Truckloads of debris from Ground Zero left the site to Staten Island to an unused landfill called Fresh Kills. The name so appropriate, unless you know that the Dutch word kill means creek. The debris was carefully sorted for human remains and artifacts like jewelry and wallets. Then science, in the name of the Office of the Chief Medical Examiner of New York, took over to do the job of connecting those fragile remains to a known victim. Dental records and x-rays were used if remains could afford those parts, but in many cases the remains could be just as small as a section of skull or foot or arm. Some referred to the pancaking buildings as the Great Shredding Machine. DNA technology became the answer. The medical examiner's office mobilized the effort to do this tedious but oh so important work of identification. And I quote, "Our first thought was that we would be able to handle the samples in-house," says Marie Samples, a project supervisor. But as the estimates of the number of bodies at the World Trade Center site continued to pile up, initial reports were as high as 7,000, those plans quickly changed. We've handled big disasters in the past, but this was nothing like anything we've ever seen. Although the Office of the Chief Medical Examiner had the largest DNA analysis lab in the country, the thought of tackling a project with that many unknown and presumed dead presented other problems for Samples and her lab. We had two big responsibilities that were clashing: our commitment to serve the criminal justice system in New York for the cases we normally handle, like sexual assault cases, homicides, and cases like that, and our role to be a support lab for the medical examiner's office in identifying the remains. We know we couldn't do both at the same time, so we decided to contract out the DNA typing work. The challenges were many. DNA is extracted from cellular material. That cellular material degrades under most conditions in a very short time. Heat and exposure to weather hasten the effect. The recovery of remains yielded DNA samples to the office of the chief medical examiner, which were then shipped to several companies that would type and profile the samples. The three major companies were Myriad Genetics, Celera, and BODE Technologies. You might remember Celera. It was in the news a lot when they were doing the Human Genome Project. Celera did most of the unraveling of the DNA code. What is DNA? Most folks today have some idea about it, that it has to do with our ancestry, our inheritance of traits, or that it creates the differences that exist between species. DNA is a pure chemical substance. Its name is deoxyribonucleic acid. It is made up of long strands composed like a ladder, having strong uprights but rungs that are interchangeable. In biology and in chemistry, there is a strong correlation between structure and function. What this translates to in terms of DNA is that the structure of its molecule enables it to carry a chemical code from one cell to another. DNA evolved in the early days of Earth's evolution. The seeds in those primordial times were like an alphabet soup of atoms of different elements. Random collisions between molecules created new combinations, some of which became the molecules that could replicate themselves, sort of like early reproduction. Other molecules could capture sunlight or make necessary energy conversions for cells. Eventually, combinations of these chemical wizards colonized in forms of cells. But it was the DNA that contained a simple but elegant code that can enable a cell to replicate itself and carry out its necessary functions. Since Watson and Crick first unraveled the puzzle of DNA's structure, scientists have been unraveling how the molecule functions. Today we know the DNA code for our genes from the Human Genome Project. Genes are a set of DNA sequences that code for a single protein that governs the emergence of a single trait. For instance, there are only 3 genes that will determine the 4 blood types that the human population represents. The DNA in our cells is located in structures called chromosomes, found in the nuclei or control centers of the cells. Humans have 23 pairs of chromosomes. Chromosomes are sort of like socks. They work in pairs. If you lose one of them, you might as well throw the whole set out. Anyway, and then that has not a good result. We also know something very curious about the vast stretches of DNA between genes. This non-coding DNA actually can be used to differentiate between 2 individuals, as these are patterns of DNA codes located next to genes. These occur in a specific number of variations. They are called markers. Their locations or loci are fixed, and combinations of these markers make up a person's DNA profile. The factor that is important here is that the patterns occur in different lengths, and by breaking down a person's DNA and targeting those markers, DNA analysts can show the difference between individuals. By selecting and analyzing multiple markers, the profile is produced. This is how it works. The first step is to take a DNA sample and increase the number of DNA strands targeted for analysis. So even a very small sample can be analyzed. This process uses the same chemical reactions and enzymes that occur in a cell. Enzymes are proteins that control chemical reactions in living things. This process is called PCR, or polymerase chain reaction. Now in English, what this is that if you have a sample of biological material that is as small as a drop of blood, you can actually, using this process, take that tiny sample and you can Xerox a targeted piece of DNA that you want to analyze. This is an extremely important process in DNA analysis. Step 2 involves a process that further selects short runs of DNA. Again, they are looking for the variations that exist for these short runs. The short runs are called STRs, short tandem repeats. These are the markers that occur as variations from person to person. Step 3 involves creating a profile for each sample based on a combination of 13 locations, better known as loci or markers across the human chromosome. What we really have here is we know that there are certain locations on human chromosomes that have been well studied. And because they've been well studied, we know exactly what percentages in the human population the variations occur. Those statistics enable us to identify a person by taking 13 of these locations and creating a profile. Step 4, if blood and soft tissue don't make up the sample, bone marrow is mined for DNA. Step 5, burned and degraded remains are analyzed by a process called mitochondrial DNA analysis. Mitochondria are little energy converters. They're located in all of our cells, and they are more numerous than a nucleus. Their chromosomes are also simpler and easier to analyze. So we use mitochondrial DNA often. Also, it's very easy to make family relationships using mitochondrial DNA because the mitochondria are only inherited through the maternal line. The last step involves a specifically modified computer database which stores the profiles. In police work, the DNA samples of convicted violent offenders are stored in a system called CODIS, which stands for Combined DNA Index System. When a DNA sample is obtained from a crime scene, it is run through this database to see if the sample matches a known criminal. In the case of the towers, profiles were run against a database made up of profiles submitted by relatives of the victims, or in some cases they had samples from the victims in the form of hair and toothbrushes, stored eggs or sperm, cigarette butts, etc. You can actually, if you look in an envelope, they can get DNA from, you're looking in the envelope because you'll leave some cells behind. There is a question of admissibility of evidence here, though. The two kinds of DNA analysis described, nuclear DNA and mitochondrial DNA, often end up destroying the sample, so the court must decide on the admissibility of this evidence. From a human point of view, would the families like verification beyond a shadow of a doubt, or would they prefer preservation of some form of the remains for burial? The procedures described above were used by the Air Force DNA Identification Laboratory to identify remains in Korea and Vietnam. The Air Force lab was instrumental in the Egypt and Alaska aircraft crashes. The Air Force labs were used to identify the remains of the Pentagon and Shakespeare crashes. Here are some statistics. There were nearly 2,800 victims in the trade tower tragedies. Fewer than 300 whole bodies were found. Fewer than 1,600 victims were identified. Over 1,100 victims remain unidentified. Over 800 victims were identified by DNA alone. Nearly 20,000 pieces of bodies were found. 6,000 pieces small enough to fit into a test tube. 200 pieces matched a single person. 10,000 unidentified pieces frozen for future analysis. And the reason why they're freezing them for future analysis is they may improve the DNA analysis techniques, and it might enable them to actually identify more people. They closed the investigation in 2005, but since then, some additional remains were found. Some were found on the roof of the Deutsche Bank building. There were also remains found in Con Edison manhole covers in the streets around Ground Zero. And they also found some remains in the pathway that the trucks took leaving Ground Zero with various debris. Given the scope of the World Trade Center disaster on 9/11, the attention and respectful care afforded the identification of the victims was professional, exhaustive, and the dedication of the staff, frankly, quite touching. The spirit and cooperation of our American scientific teams involved in all aspects of 9/11 will surely defeat the terrorists.